Hello students, welcome to mathematics class. Students, this is part 4 of the chapter Factorization. In this part 4, we will learn very important method of factorization by using algebraic identities. Children, as a continuation of this part 4, after learning factorization of algebraic expressions by using algebraic identities, I would like to discuss even the questions from exercise 14.2. So, in the beginning itself I am mentioning you can watch this video as a repetition and you need not watch it in a one go. Either you can download and watch as a bit by bit, as a part by part, since it is going to be a big longer session and I will complete till exercise 14.2 in this part 4. Now coming to the factorization using identities. Children, you are already well aware of what are algebraic identities and you have seen them both algebraically how to get them and geometrically how to interpret them. First algebraic identity is a plus b whole square, which is equals to a square plus 2ab plus b square. Second standard algebraic identity is a minus b whole square, which is equal to a square minus 2ab plus b square. And third important algebraic identity is a plus b into a minus b, whose product is equal to a square minus b square. And summarization of these three standard algebraic identities can be taken in one form called x plus a into x plus b, which is equals to x square plus a plus b times of x plus ab. Now children, having these four important algebraic identities, you can factorize some of the algebraic expressions. Now let me consider one example. Here factorize x square plus 8x plus 16. Children, the moment you see this, you will have a confusion. This algebraic identity, this algebraic expression, it is of the power 2, so we say quadratic expression or quadratic type algebraic expression. That's why you could see here powers of variables as a being 2, power of b being 2. Now this x square plus 8x plus 16 can be expressed as x square plus, you watch here, 16 can I write as 4 square, that means it look like a square plus b square in the third term. Middle 8x can I express as 2ab, that is what I have to look for. 2 into x into 4. Now 2 into a into b form it has come. So the moment I see this, our observation should be that it is looking like a square plus 2ab plus b square, where a is substituted as x and b is substituted as 4, and we know this standard algebraic identity, one tells us that a square plus 2ab plus b square can be written as a plus b whole square. Therefore from algebraic identity 1 a square plus 2ab plus b square can be written as a plus b whole square. Thus, x square plus 8x plus 16 can be expressed as, instead of a I will substitute x, plus instead of b I will substitute 4 whole square. So, thus factorization of x square plus 8x plus 16 is x plus 4 whole square. We will conclude it. Okay. So, this is the procedure of solving. Okay. We say this is the required factorization. Now, let us go for another example. Here in this example number 4, factorize 4y square minus 12y plus 16. The moment you saw negative, it somewhere resembles a square minus 2ab plus b square. So, we will search with this, okay, where it can be factorized as a minus b whole square. So, observe here 4y square can be written as 2y whole square. Okay. We know that 4y square is equals to 2y whole square, okay, and 9 is written as 3 square. Therefore, 4y square minus 12y plus 9 can be written as 2y whole square, and here 3 square. In between this, can I write minus 12y as minus 2ab? So, that is the question. So, I will attempt writing minus 2ab form for this minus 12y. Suppose if it is equal, how do you say? So, negative sign is there, no problem. Y 12y. So, can I write this as 2 into 2y into 3? Obviously, yes. So, 2 into 2y is 4y into 3 gives definitely 12y. So, with minus sign, thus this a has come here, this b has come here. So, it definitely looks like, now it is, therefore, it is looking like, or it is looking, or it looks like a square minus 2ab plus b square, where what is a? In the place of a you could see 2y, and what is b? In the place of b I could see 3. Therefore, 4y square minus 12y plus 9 I can factorize as 2y minus 3 whole square. Is the factorization of given algebraic expression. Okay. Why I could say 2y minus 3 whole square? Because a square minus 2ab plus b square is a minus b whole square. Next, coming to the another example. In this example number 6, we are asked to factorize 49p square minus 36. Observe, there are only two terms. When there are only two terms, we have a square minus b square form, which can be factorized as a plus b into a minus b. That means I can write 49 p square minus 36 as 7p whole square minus 6 square. It looks like a square minus b square, where a is equals to 7p and b is equals to 6. So, therefore, we can write this 7p whole square minus 6 as 7p plus 6 into 7p minus 6. Now, coming to the another example. Before that, is the factorization will write? Is the required factorization? Is the factorization of 49 p square minus 36. Now, coming to the example number 7. Factorize a square minus 2ab plus b square minus c square. Very important question, children. It is very important question. Now, first, since a square minus 2ab plus b square is factorized as a minus b whole square, this first three terms I will write as a minus b whole square minus c square. So, the first three terms I have factorized first. Now, you know, children, we can change the variables. Instead of a square minus b square, I can write x square minus y square is equals to x plus y into x minus y. This is the third standard algebraic identity, but letters are different. I am using here in this x and y as variables. It looks like x square minus y square, where x is a minus b and b being a y, y is equals to c. Thus, we can factorize this as x plus y into x minus y, where x is substituted back as a minus b plus y is substituted as c into this x a minus b minus this y is substituted back as c. So, the factorization of this given algebraic expression is the product of trinomial a minus b plus c into another trinomial a minus b minus c. Remember, that is a very important question. Factorization of this a square minus 2ab plus b square minus c square is the product of two trinomials. Okay, that is what we got, a minus b plus c into a minus b minus c. Okay, after simplification we get this only, this answer only. Now, coming to the example number 8. Children, in this example number 8, again this is very important question. We will consider m power 4 minus 256 as first m square whole square minus, 256, it is the square of, if you have any doubt, don't get confused. First, do factorization. 2 128s up, 2 64s up, 2 32s up, 2 16s up, and 2 8s up, 2 4s up, and 2 2s up, which means 256 can be written as 1 2 3 4 5 6 7 8. So 2 to the power 8, where this m power 4 minus 2 power 8 can be written as 2 power 4 whole square, or I can say 256 is the square of 16. So we wrote m square whole square instead of m to the power 4. Instead of 256, I have written 16 square. Now it looks like a square minus b square only, okay, where a is m square and b is 16. Therefore, the factorization of m power 4 minus 256, we can do it as m square plus 16 into m square minus 16. Children, you tell me, we can write, since a square minus b square is equals to a plus b into a minus b. So, I have used this standard identity third. Now, here I am substituting a as m square and b as 16 back. So, now you tell me, children, can I stop it here, factorization? Is there a requirement of further continuing? Yes, there is requirement of further continue. What I can continue here? Now watch here, this m square minus 16, further it can be factorized. How it can be factorized? Let me explain by taking new page. Now students, I am taking here further ones, m power 4 minus 256, I have written as m square plus 16 into m square minus 16, where this m square minus 16 further I can write as m square minus 4 square. Now it again looks like a square minus b square, which is the product of a plus b into a minus b. So by considering this identity, m square plus 16, this one of the multiplicand comes as it is. So I am writing m square plus 16, which cannot be further factorized, I will keep as it is. This m square minus 4 square can be factorized as m plus 4 into m minus 4. Why? Because here in the place of a, you can observe as m, in the place of b can observe as 4 and substitute, okay, a plus b as m plus 4 into a minus b as m minus 4. So can I say that now it is factorized completely? Yes. So children, remember the factorization of m power 256, m power 4 minus 256 is the product of three binomials, one m square plus 16, another binomial m plus 4, and third binomial is m minus 4. So this is the required factorization. Now coming to the factors of the form x plus a into x plus b. You observe, children, in general the factors of x plus a into x plus b. You have this x plus a into x plus b being x square plus a plus b times of x plus a into b. Suppose if you have got this form, we can factorize it and write as x plus a into x plus b. How we can do this? Here, in general, for factorizing an algebraic expression of the type x square plus px plus q, we find sum of two numbers such as equal to p, product of two numbers such as q. Let me explain with example. Here I have taken x square plus 5x plus 6, where p you could see as 5. I want it as a sum of two numbers, and you could see q as 6, where the product of those two numbers. Which two numbers? Which I have taken as sum. So I have to choose such a way. What I can choose? Here 5 can be written as 1 plus 4, 2 plus 3, but when I write 5 as 1 plus 4, 1 4s of 4 will come, not 6. But if I write 5 as 2 plus 3, their product is 6, isn't it? So here a plus b is equals to 5, a into b equals to 6, therefore a is equals to 2 and b equals to 3, or a equals to 3 and b equals to 2, I can say. Thus x square plus 5x plus 6 can be factorized as x plus 2 into x plus 3. Now you can cross check by multiplying x plus 2 into x plus 3, you will get x square plus 5x plus 6 only. It is the factorization. So children, this is very important, this logic of working out. If a plus b equals to 5 and a into b equals to 6, identifying what is a, what is b. Okay. So that is how we make use of this identity. Now let us solve this question. Find the factors of y square minus 7y plus 12. See, when you want to factorize this, you need to observe a plus b as a minus 7. Why? Because we have so far learnt x square plus a plus b times of x plus a into b, where all terms are positive, equal to x plus a into x plus b. This is the identity which you have learnt. That means, children, observe this algebraic identity gives the factorization of this trinomial, that is x square plus a plus b times of x plus ab, which is the product of these two binomials, where all terms are positive. So I have to make it all terms being positive, whereas sum of two numbers is minus 7 and product of two numbers being 12. So now I have to search for which two numbers are they, what is the value of a and b. So, if A plus B is minus 7 and A into B is 12, how to search for the values of A and B? This is the very important technique. Now, I will tell what are the possible products of two numbers giving 12. The possible products of two numbers 12 is 1 into 12, 2 into 6 and 3 into 4. Now see children, when I consider A as 1 and B as 12, their sum cannot be minus 7. Their sum is 13. Next, when I consider A as 2 and B as 6, their sum is not minus 7 or 7, their sum is 8. Now, when it comes to the A, when I consider as 3 and B I considered as 4, yes, their sum is plus 7 but not minus 7. If I want minus 7 as the sum of two numbers, I need to take this simple way. If A is minus 3 and B is minus 4, then their sum becomes minus 7. Correct now? Then their sum becomes minus 3 added to minus 4 gives minus 7, and their product A into B becomes minus 3 into minus 4, which is minus into minus plus 12. Now the value of A and B suits as well as their sign also suits. So by substituting here x square, rather x square, I have to take y square now here, y square minus 7y plus 12 can be substituted as, instead of variable x I have y, so I will take y. Instead of plus a I have to take minus 3, because plus of minus 3 becomes minus. So into y minus 4. Watch here, the product of y minus 3 into y minus 4 definitely gives you back the value of the given algebraic expression, or expression will come. So y minus 3 into y minus 4 is the required factorization. Now coming to the another example number 11. In this example number 11, you watch all three terms. First term is positive, next term is negative, and third term is negative. So z square minus 4z and minus 12, which I can write as z square plus of minus 4 times z plus of minus 12. That means sum of two numbers supposed to be minus 4 and product of two numbers supposed to be minus 12. Okay, so the same possibilities, we will get 12 from 1 into 12 or 2 into 6 or 3 into 4. Now I have to see which two numbers suits well. Here 1 12s are 12, but their sum or difference is not 4, it is 11 or 13. 2 and 6, their sum is 8 but difference is 4, this is somewhere suiting. So 3 and 4, their sum is 7 and difference is 1, so it won't suit. Only 2, 6 are suiting well. Now if I consider the 2 and 6 as the numbers A and B, now which number to be given positive, another number to be given negative, which are they? Now suppose if I consider 2 as a positive and 6 as negative. Then minus 2 and plus 6 are 2 and minus 6. They are the only two numbers, two possibilities. So, whereas the two possibilities amongst the selected numbers, that is minus 2 and 6, are 2 and minus 6. Now consider, if I take minus 2 and 6, their sum will be plus 4. If I consider 2 and minus 6, their sum will be minus 4. So that time, by that condition, minus 2 and 6 get failed and 2 and minus 6 get true. Therefore, A will be 2 and B will be minus 6. Okay. So through this logic, A will be 2 and B will be minus 6. I am working this entire logic behind the screen, and in the center of the screen or on the stage, or when it comes to the writing the solution, I will write this much only. If A plus B equals to minus 4 and A into B equals to minus 12, therefore, or then A is 2 and B is minus 6. Okay. When we have x square plus A plus B times of x plus A into B, which can be written as x plus A into x plus B, in that identity, here z square minus 4z minus 12 can be written as, where here variable is x, here variable is z. So I will write z plus, instead of a I will write 2 into z, instead of b I will write minus 6. So plus of minus 6 becomes minus 6. So I will write minus 6 straight away. So z plus 2 into z minus 6 will be the factorization, is the required factorization. If you have any doubt, you can multiply these two and check whether you will get the given algebraic expression or not. Okay, that checking you can do it. Now let us get into another example number 12. Children, in this example number 12, watch 3m square 9m plus 6. By looking at this, you will get confused that it cannot be factorized. But can I write it by taking 3 as common out first? This algebraic expression, 3 into m square plus 3m plus 2. That means I am using first technique of algebraic expressions factorization, or factorization of algebraic expression, that is taking out common factor out here. After that, then I will go for this 3 into m square plus 3m plus 2 using algebraic identity x square plus a plus b times of x plus ab, where sum of two numbers is 3 and product of two numbers is 2. Here it is. If a plus b equals to 3 and a into b equals to 2, then a is equal to what and b is equal to what? It is the background work which you have to do. So how will I check? I will once again explain. So this is the identity which I are using. I am writing it here. If I want to check, first take the product of two numbers, that is 2, and write what are the possible factorizations, that is 1 into 2. There is only one possibility, there is no other possibility. So their sum is equals to 3. Yes, it suits here. So straight away 1 comes and B comes as 2. There is not much work. Now 3 into this m square plus 3m plus 2, now it can be factorized as, here variable is x, then x plus a comes. Here variable is m, so m plus comes. So m plus a, where a is 1, into m plus b, where b is 2. So therefore given algebraic expression 3m square plus 9m plus 6 can be factorized as 3 into m plus 4 into m plus 2 into m plus 1, this m plus 1 into m plus 2. I have written m plus 2 into m plus 1. Product, we know associative property a into b into c is a into c into b also, like we can write. It is the required factorization. So children, I will wind up this session with this, and next session I will continue from the exercise 14.2. So till then, take care of yourself. Jai Hind. Thank you.